Hi everyone and welcome to this new video. In this video I continue the BSCP guide, and specifically in this video we're going to talk about JSON Web Tokens and the typical attacks that you can do on JWT. To this end, in this video we will introduce the idea behind JSON Web Tokens, how integrity is achieved in a JWT, and what are the main attacks over JWTs, and we will show 3 different labs taken from the Portswigger Web Academy to help you prepare for the BSP certification. So I hope this video is enjoyable. I hope you get something out of it. If you do, you can subscribe to the channel, you can share this video with like-minded people, and you can also support me on Patreon, where you have access to this content, more BSCP related content, and general content that I publish online through videos, and also just like code and things of the sort. So for more details, check out the Patreon page. Thank you very much and enjoy the video. So let's get started by talking about JSON Web Tokens. Now, JWTs are a mechanism used to transmit information between the browser and the various backends it interacts with using a JSON format. Now, what kind of informations are exchanged through a JSON? Now, the information contained in a JWT is used to manage user identities, which means authentication information, and also to manage access control mechanism, which means authorizations information. So the information is a JSON. It is typically used for authentication and authorization purposes. Now, since these information are given to the browser in the form of a JSON object, to make sure that a malicious client is not able to simply modify this information in order to bypass authentication or authorization checks, the JWTs are protected with integrity. So with integrity mechanism implemented through cryptography. So cryptography and integrity is a key aspect of JWTs, because without integrity, anyone would simply modify the content of a JWT and they could claim that they are the administrator and things of the sort. Now there is this website jwt.io. You can play online with the JWTs. So you can just go here. Let me show you the website itself. Just go here and you have a JWT decoder and a JWT encoder. So you can play around with these things. So let's try to understand what a typical JWT looks like. So a typical JWT looks as follows. So this is a typical JWT, and typically we see this JWT within the request header put into the authorization header. So look at this. Here we have a request for the API user profile, and in the authorization we have bearer with the JSON Web Token, with the JWT value. Now this value is generated by the backend, it is signed by the backend, and typically it is generated after a proper authentication. So typically what happens is that we give our credential, the backend checks if they are valid, and if they are, it generates a JWT which we can get through a JSON response. Like look at this, we have an application JSON, here in the token value we have the JWT itself. And JWT is handled, by the way, by the JavaScript of the browser. It is not like the cookie, which is handled by the browser itself, because the cookie is an internal mechanism to the browser. The JWT instead is handled by the JavaScript on the page. There could be libraries on the client side that deal with the JWT. On the back end, of course, you can have many different libraries in many different programming languages. You can have them in Python, in Node.js, in Java, in C#, depending on the environment you're dealing with. Now, JWTs have a common structure made up of 3 different elements: the header, the payload, and the signature. So the header contains metadata related to how the signature of the JWT was computed and to how the signature should be checked by the backend. For example, here we can say that, oh look, this JWT is of type simple JWT, and the algorithm used to protect the integrity is HS256. So this is a symmetric scheme, it's an HMAC symmetric scheme, and it's called HS256. So the server reading the header knows how to check for its integrity. So that's the idea. After the header section, we find the payload section. Now this part contains the data related to the specific application which issued the JWT. So here we can find application specific data, and this data in particular can be used to implement access control checks, and also to manage user identities. So here is the content of the payload section. Oh, and by the way, these elements of the JWTs are found within this token separated by dots. I mean, look at this. Here we have the first element and then the first dot, then we have the second element and then the second dot, and then we have the third element. So here we have this is for the header, this is for the payload, and this is for the signature, as we will talk in a bit. So you have to split them by the dots. So as I was saying, the payload contains application-specific data. Now here there's an example payload. So here the various property means sub is the subject related to the JWT. So you can think of this like a user ID. Here we have the name of the user. Here we have an admin property. So for example, this could be used to implement access control checks to make sure that if you access the admin page, only people with the JWT admin true can do that. And then there is this I@, which is the time at which the JWT was generated. It was issued to the user. Now, this specific JWT does not have an expiration date. Typically, you will also find an exp property, which defines the time after which the JWT is no longer valid. And so by subtracting exp with I@, you get the total duration of the JWT. In this case, there isn't, but it's okay. So basically the idea, in the payload, we put application-specific data used to implement, used to manage user identities and implement access control checks. Finally, we have the signature. The signature is what makes the JWT secure. Because let's consider this. If the user can simply put admin true to whatever they want in the JWT without any integrity check, they would have an easy way to bypass all access control. So, if JWTs are used for access control purposes, we must ensure the integrity of the JWT. And this is done by using the signature. The signature is generated by the server when the JWT is issued the first time, and then every time the JWT is used, before usage, the server makes sure that the signature is valid. So that's the idea. Now, there are different mechanisms to obtain integrity over a JWT, but all of these mechanisms have to do with cryptography, of course. And there are two main methods. One based on hash-based message authentication code, that is HMAC, and another based on digital signatures. Now, both of these methods provide integrity, so provide a way for the server to realize if the JWT has been tampered with, but they work differently. Now, the HMAC has a symmetric structure, meaning that we have a single key that is used when you generate the JWT and when you need to verify the signature of a JWT. So we have a single key. And this is the HMAC. So we have a key, we have a message, and here we compute the tag, the message tag. This tag is added as the signature portion of the JWT. The only way to compute the correct tag for a given message is to know the key. If you don't know the key, you cannot really figure out the correct tag for the given message. This means that if a malicious actor modifies the message, then they also have to modify the related HMAC tag. And to do that, they must know the key. So that's basically the idea. If they don't know the key, they cannot really modify the signature to match it with the message. Then we find also digital signatures, which provide, once again, data integrity and authentication. So because both of these things is not just for integrity, but also to authentication, to make sure that the one who generated is the one who owns the key, basically. So that's the idea. And this one uses asymmetric cryptography. So here we have a private key and a public key. To sign the message, we need the private key. And so here we typically what happens is that first we compute an hash between the message using an algorithm, and we have the digest, and then we actually encrypt the digest with the private key, and this is our signature. So the signature is computed with our private key. To verify the signature instead, the public key is sufficient, which means that the server generates the key, and then anyone who has the public key can verify the signature. And this works by taking the public key, the message, the signature. Once again, you compute the hash of the message. Here, let's assume that there is a simple hash function, so that this hash is not based on an algorithm, it's just fixed in time, so that the hash is the same throughout the messages, throughout the computation. And basically, here we decrypt with the public key the signature, and this is the original hash, and then we make sure that they match. The original hash matches with the hash of the message. So let me just write it in snake case, this one too, to make more consistent. Perfect. So basically that's the idea, and also this public key should be like this too. So that's the idea with the way that the integrity is achieved. Now, what are the main attacks over JWTs? Well, as I said, since JWTs are used, for managing user identities, to implement access control checks and stuff like that, it is vital, it is key, it is super important to ensure that the token cannot be maliciously modified. That is, attacks on JWTs are all about bypassing the integrity check. If you bypass the integrity, you can put anything you want on the JWT. This allows you to obtain any sort of access into the system. So all security of the JWT has to do with ensuring integrity, and all attacks have to do with finding ways to manipulate integrity, either directly, indirectly, and things of the sort. This list of attacks is taken from my BSCP JWT checklist, which is available in the Git of the Patreon, under Patreon subscription. For the JWTs, this is the typical checks. These are also related to the laboratories, and there are for other vulnerabilities, other checklists like the following one. So if you're interested in that, check out the Patreon for the project. Let's analyze 3 laboratories taken from the Porswigger to, understand all these concepts more in detail. So let's start from the first one, which is the simplest, of course. So let's open this lab. So let's open this lab. I'm going to activate the lab here, access the lab. So here I have basically, let's open here the browser, Chromium browser here. So the page has been loaded. We can give it to the browser. Now, if we check for the lab description, it says that this lab uses a JWT-based mechanism for handling sessions. However, due to implementation flow, the server does not verify the signature. Once again, we need to delete the user Carlos by being admin. So here is the full description. We need to delete the user Carlos to be admin. And we can log in with our own credential, winner Peter. So let's log in. Winner Peter. So here we have our session. Then, we can see, for example, that we are using JWTs, because if we go into the local storage of the website, so what do we see here? We see, so let's see. Let's see. Actually, this JWT is implemented through a cookie. So it is sent back to the client as cookie. Look at this. We log in with our credential, and here it gives us a JWT, and it sets this JWT as a cookie. So that's the idea. Now, this is the request for the my user account ID winner, basically. And here we can see that, for example, if we just zoom in here on this, on the inspector, we just look at this parameter, notice that here with the code URL, with the code base 64, and we find algorithm RS256, and this is the key ID. So this is an ID that identifies the key used to protect the integrity of this JWT. Now, let's just, like the first thing you should do when testing this thing is just a really basic attack. Let's just modify the sub ID, the subject, basically. Let's just write administrator here. Now the subject should identify the user, right? So notice, look at this. So if we sort of just modify the administrator here, it says found/login, follow redirection, and here, let's see what happens here. I have this administrator sub. But if you notice here, I have access to the admin panel already. Like it logged me, it brought me to the login page, but I can see the admin panel. Now, if I go into admin, here, notice that I can access the actual admin page, even though I did not properly authenticate as an administrator, which means that I can do simply delete and then username Carlos, and this should allow me to complete the lab. Here it says found, and if I just go back to the admin stuff here, notice that I have solved the lab. Now, what happened exactly? Why were we able to solve this? Well, the idea was that we were able to modify the JWT. We were able to put into our JWT the subject to administrator, and the server did not check at all the integrity of the JWT. This is why, of course, this attack is trivial. Website should ensure the integrity of the JWT, but if they don't, this is what can happen. You can just modify the value to whatever you want, and if by modifying the value you get access to more resources, to like more pages and stuff like that, you're good to go basically. I mean, that is a very simple attack that if you find a backend that does not validate the JWTs, this of course is golden. Also, remember that in more complex software, maybe you don't have just a single JWT. Maybe you have multiple JWTs. So sometimes web servers, they can validate some of them, but not all of them. And to actually achieve a break in security, to actually break a security boundary, you must make sure two things. One, that you can modify the JWT with the values that you want. Second, that the backend actually uses the modified JWT and if the backend uses the modified JWT, then you have to understand, okay, how can I modify it in order to get access to more resources? So that's the idea. And so this is a simple lab with a simple solution. So let's go for the next lab. So this one. So once again, this one is to solve this lab, modify your session token to gain access to the admin, then delete the user Carlos. So basically, that's also the idea. We have the same thing as we mentioned before. So by the way, one thing that I think is useful is that, for example, let's say that in this case, we want to analyze the JWT. Well, we can actually use, we can go into the extensions here. We can edit this JWT editor. So we can just load this thing. And now in repeater here, notice that I have access to this new tab, Json Web Token Editor. So here it's gonna read the serialized JWT, and it's actually gonna break it into the different components, like header, payload, and signature. And here, of course, I can simply modify the sub itself. I can modify the sub, and it's gonna modify this, and I can just like copy it, and I can put into the request itself. Of course, in this case, it's already done by the stuff. So, you know, if I just do winner here, it's gonna modify it. Let's see, it's gonna modify into winner. So with Json Web Tokens, with this extension, you can easily, you know, play around with the token itself, and also there are a bunch of attacks that you can do with this extension. So let's actually do this other lab. So what was the lab here? It was spawned. So once again, the idea is we want to log in with the winner Peter credentials. And here we want to delete all of this because we don't care about that anymore. And look at this, now that we have the JWT editor extension, here it's gonna mark in green the request that have a JWT. So in this case, we have a JWT, so it is marked in green here, and we can use this to understand, okay, look, we find the header, we find the payload, we find the winner. Now, in this case, what we can do is, in the header here, sometimes it is possible to specify the so-called known algorithm. And the known algorithm means what you think it means. It means do not protect the JWT with integrity. Like, do not apply any check whatsoever. Just take it without integrity. So how do we do this attack? Well, manually. So let's first show manually, because the extension is useful, but let's learn how to do it byte by byte. So we would need to modify the header here. We can remove the KID, and we can put alg none. Look at this, we put alg none. Now, if you send this, it's gonna say found login. So let's go into the admin. Let's go into the admin, and here it says unauthorized. So this is the first step. Also notice that when you edit this with inspector, actually, here we have to remove this equal. You have to remove this equal, which basically is this percentage 3D. So you want to remove that basically. So of course we are still unauthorized. Now here we have to change the subject to administrator. We are still unauthorized. The last thing that we need to do is we need to drop the signature itself. Now the signature is this last portion of the JWT from the final dot to the end. So we're gonna put an empty signature, And look at this, now it works. So why does it work? It works because we did 3 modifications. We put algorithm none, we edited the payload in the administrator, and we dropped the signature. Now, 2 of these things have to do with bypassing integrity, and the third one is just to exploit it and become administrator. So to bypass integrity, you just need to do the first and the last thing. You need to put algorithm none in the header, and you need to drop the signature. Once you've done that, you can put anything you want here. I can also put back winner, for example, and now it's going to say unauthorized, but it's because I'm trying to access admin. If I access my account, profile winner, it's going to say okay. So here I can put whatever I want here. I know I can put any sort of subject I want. So basically that's the idea. If I put administrator, of course, I have to put my admin, so to reach the admin panel. And now that I reach the admin panel, I can just delete. I can just do delete username equal Carlos. They really do not like Carlos. So that's the solution for the second lab. Algorithm none, and you drop the signature, and then you see if this works out. Remember also to remove this padding here because sometimes it's not needed, but basically that's the idea. So this was the second lab. As I said, the solution is change algorithm none and remove the signature. So this is the new, and then this is the request for victory. Finally, we have the third lab. So let's go into the website. Let's open the lab as always. So this one is a bit more interesting because it is less trivial than the others. So what's the idea here? Well, the idea is that this token uses an HMAC construction to protect the integrity. And as we established, HMAC uses a key for creating the tag, the message tag. So when we're dealing with HMAC, so how do we know that we're dealing with HMAC? Well, here let me log in. Here is my account. I go into burp, I remove everything, and then here I have my post login. So look at this, I have my post login. Actually, it's not this one, it's my account page. Here I have the JWT itself. In the header, look at this, it says alg HS256. Now this uses an HMAC scheme, and HMAC uses a private, like a symmetric key in order to create the message tag starting from a message. Now, how do you break this scheme? Well, sometimes the key that is used within this scheme is actually a weak key, and it can be brute force using specific word list. For example, the rocku.txt word list is such an example. So what's the idea here? How can we solve this lab? Well, the idea behind solving this lab is to discover what was the signing key used to sign these JWTs, and once we know the key, we can generate custom JWTs with custom properties. So let's get into the write-up here. So solution. Well, the first thing is that we want to download a tool called JWT tool. I suggest this tool so that you can also do it without burp, whatever things you use. So let's go here and let's just make, actually in this case I'm just gonna download it into this current folder. In your case you can also try to make the tool JWT directory. I'm just gonna remove these commands because it's not particularly needed. And then I do into cd JWT tool. So I go here. Here I'm gonna create a Python virtual environment. I use VM. I think I should switch to UV because I heard it's pretty good, but for now I'm using VM. So you just install the requirements. At this point you can execute the tool itself. Look at this JWT tool, and here we have the basic idea. Now, how does it work? Well, if you want to crack it, you can say JWT tool -c, then you can put a dictionary, and then you can put basically the JWT itself. Now, with respect to the dictionary, actually, I suggest you to use the, let's see if in the lab description, it's gonna say which JWTs to use. Let's see, word list of common secrets. So we have these JWT secrets. So let's just throw this, and let's just do wget. So I'm just gonna wget, how big is this list? Wait, how is it called? JWT secrets. JWT.secrets. So it's 1.2 megabytes, not even that much. So let's go into the terminal. Actually, it's going to the README and then into the terminal. So which terminal was I using? Okay, I was using like this, so it's going to be jwt.secrets, jwt.secrets.list, and then the final argument is actually the JWT that we obtain from the server. So this we can just take it from burp. We're just going to copy this. We put it into this tool. So look at this command. I'm just going to execute it, and it found immediately that secret1 is the correct key. So it found the key used to generate this JWT. And by the way, this process is very similar to hash cracking, to the cracking of hashes, for example, something that I've discussed in the Linux and Windows privilege escalation series. So if you're interested in that, go check them out. So we get that the secret one is the secret use. At this point, you know, we know, okay, look, the structure of the JWT is this one. Okay, here we have the expiry time, and we can forge a new JWTs. So what's the idea here? How do we forge a new one? Well, we can start with the basic payload. We can put the administrator subject. So we're gonna pretty much change this. We're gonna copy this value. And so basically, the idea is that now we have the header and the payload. And we don't put the signature here. Like, to create a new one, we can put the T option. We put the header, which we know the value, the new payload, which we want the value, and then we put the algorithm and the password. So let's actually copy it into a different buffer to make sure that we got this right. So this is from an old video. So let's do JWT tool. Here for the header, we're going to copy pretty much the same header basically. So same header until the end here. So the only thing that's going to change, of course, is this payload. Then we put HS256 and then we put P secret1 that we found through the brute force. So we do this and let's say token header values. Add a value, continue to the next step. We want to say continue to the next step. We want to say continue to the next step. And that's it. We have generated the signature. So now we have a new valid signature basically. We can put it into the burp here, into the session cookie. I can just copy it. I can go into admin, and if the attack worked well, notice I get 200 OK. I get 200 OK, meaning that I was able to crack this, meaning that now I can just delete the username Carlos, and that's it. I delete the username Carlos, and I've solved the lab. The lab is now solved. So to recap, what did we do here? Well, we brute force the symmetric key used to generate this JWT. And we recognized there was a symmetric key because the algorithm was HS256. Then we tried to brute force it, and actually we immediately found the answer. So if you find a JWT that was signed with a symmetric key, it could happen. Typically, it's really hard to know the key, but sometimes the key use is weak, and so sometimes you can just crack it, and once you have the key, you can generate arbitrary JWTs. So basically, that's the idea. And so this is it for this video. In this video, we introduce the idea behind Json Web Tokens. We show the importance of ensuring integrity on JWTs. We discuss roughly on the attacks on JWTs, but basically that's the idea. I hope the video was enjoyable. I hope you got something out of it, and to the next video. Thank you very much for watching.